All right, hi everybody. We're going to get started at 12:02, which is in about 2 minutes, just to give people a bit more time to arrive. So just hang tight. All right, let's get started. Thank you everybody for showing up and attending. Let's get started. So, hi everybody. We're the team at the Pacific Math Association, which is a group of 4 high school students: me, Nividh, Alan, and Suyash. Um, and we teach classes every week for math counts and AMC level sort of stuff. And today we wanted to go over a few um, concepts and things to revise just before the math counts chapter test, which is coming up. Before that, let's introduce ourselves. So again, hi everybody, my name is Ram. I'm a sophomore in high school, and I'm from Oregon. We're all from Oregon. And I really like doing math, and I did math counts back in 8th grade and 7th and 6th grade, and I really liked it. We all got to national math counts and went through all the levels, so we sort of want to pass on teachings from each sort of level and what you can improve. One thing I like doing outside of math is playing basketball and following the NBA. So that's pretty cool. Nividh, you want to introduce yourself?
Hi everybody, my name is Nividh Singh, and I've also competed in various math competitions like Ram. And outside of math, I really like to wrestle, and I really like biking and snowboarding. Suyash, do you want to introduce yourself?
Yeah, hi. So I'm Suyash. I'm a sophomore at Sunset High School here in Oregon. So I've been participating in math competitions for many years now, and even no matter how far you get, there's always something to enjoy in them. Outside of math, I enjoy playing chess and listening to music.
Uh, I'm Alan. I am a sophomore at the Davidson Academy. I have also done many math competitions. I'm really interested in math and science. That's the main things. Uh, so welcome everybody
All
to
right.
this meeting.
All right. Thank you, everybody. Thank you, Alan. And so that's us. So let's just go over some basic things regarding math counts and how it works. So most of you are familiar with math counts, a series of math competitions for middle schoolers. Um, so one of the first rounds, which is the chapter round, obviously math counts has practices that your school does organize, but there are also competitions that happen throughout the year. So one of the first rounds for that is called the chapter round. That's coming up soon. It's just in less than a week. So this strategy session is designed for some last minute revision of concepts. So we're not trying to cram anything, but just make sure you sort of know everything. Basic strategies for problems, as well as test taking strategies. So things you can improve to improve your performance, be prepared for the actual test, uh, which you may not have practiced as much than just doing individual problems. Even if you're not in math counts or not participating or not doing it quite yet, or anything like that, this session will still be useful because math counts problems are pretty they help in a lot of sort of different areas of math, just outside of math counts or even math competitions. So yeah, one thing to remember for this session, this is a hands-on session, which means that we're going to be doing math problems as well as just us four talking. So yeah, make sure you have a piece of paper, have a pencil, your brain's open, and you're ready to do some math. All right, so make sure you get some sort of writing utensil and to make sure you can just jot down some stuff as we're talking. All right. And yeah, all the advice we're going to be giving, as well as the problems we're going to be going through, and all that sort of strategies, all that is based on our own experiences. So we've sort of compiled all this stuff based on what we experienced through math competitions and things we thought were important. And we hope that the experiences and strategies we provide will be useful for you all in the future, the sort of next set of people who are going to do math counts. All right. And as always, feel free to ask any questions in the chat at any point, or unmuting at appropriate times. So one of us will definitely be able to answer your question through the chat. All right. So that's the basic overview of what we're going to be doing and the sort of introduction. All right, let's just go through the plan of this session real quick. Yeah. Nividh?
Before we get started, I just want to let everybody know, for some of the people who are asking in the chat and so on, that we will be sharing the slides on our website and we will be sharing the recording. So if you want to reference the slides later on, or if or something goes a little bit too fast for you, they will be on our website after today's session.
Yeah, we'll be uploading these in the website after. Nividh, you want to put the link for the website just in the general chat? If you guys haven't seen our website yet, you can check that out. And we're going to be holding classes every Monday as well. So there's going to be a class tomorrow. So make sure you register for that. And yeah. All right. So first we're going to talk about test taking tips and tips while solving problems. So this is going to be less sort of focused on actual direct math problems. We're going to talk about that sort of stuff initially. After that, we're going to go through specific problems and concepts that appear often in math counts, as well as strategies to solve them. So strategies to solve, say, algebra problems, number theory problems, that kind of thing. So the first segment is going to be pretty disjoint from the second segment. And at the end, feel free to ask any general questions and we can answer. And we're also going to have a fun Kahoot, which is sort of a countdown style round. Obviously, you're all competing against yourself. Nothing much of a competition, but should be fun. All right, so that's the general plan. Let's get into some test taking tips and strategies while solving problems.
All right. So first we'll start to talk about things to remember and do before the test. So before the day of the chapter competition, the morning of the chapter competition, and just in general before you go into the room and start taking the test. So we're going to talk about things to do a short while before the test and tips to talk about during the test so you can perform the best you can. A lot of this is going to be about how to prepare mentally for the test and how to do good when you're mentally prepared. On a larger scale, practicing for the test is really important throughout the year. This includes things as learning new concepts and practicing them. But in more short term, in the weeks and the days before the competition, do old practice tests. A lot of times, math counts questions are similar from previous years to the current year, and just in general, you'll see that if you can do previous year's questions or you can learn how to do them, then you'll do good in this year's competition as well. And it also helps you to get into the rhyme of solving problems one after another, and it lets you know your own pace. And the more you practice and the more often you practice, the better you're going to get and the faster your pace will become, and the more you'll get kind of experience in how to do this. They also kind of serve as a review of concepts over multiple areas. Since math counts is in a lot of areas, it's really important to review all the things you've learned because throughout the year you'll learn a lot of things through school by yourselves, however you learn things. And a lot of times you forget small details and concepts you've learned, or you just forget a little bit. And doing old practice tests make sure that you kind of review all the concepts you've learned and then it'll prepare you good for the test. Also, one thing that a lot of us like to do is when, as the time comes closer to the competition, we move from older tests to newer tests. So, like for example, in the 2020 competition, a week before we'd start with the 2013 competition, and then every day we'd move on, do an extra year, and all the way until we were doing the 29 competition, like 2 days before the test. That way, we have the most recent test right before our test. And make sure you practice both sprint rounds and target rounds because the pacing, the types of questions are all different. So it just gives a general idea of how it is. And you can easily find old chapter rounds online by simply using Google. You can search up Mathcounts chapter round 2013, Mathcounts chapter round 2012, and most of the questions should be there.
One thing I'll just say, if you don't know what the sprint and target round are, it's all explained in the PDF files when you search it up. So sprint round's a bit longer, target round's a bit shorter. But yeah, make sure you can just use Google to find the tests and make sure you're doing them in a timely manner.
Don't do too much math the day before the test. This is really important because a lot of people, I even used to do this, the day before the test, I used to start cramming and I started practicing everything I knew. And I just started doing a lot of math the day before the test because I thought this would be most beneficial. But extremely last minute cramming is not effective, particularly for a non-memorized based test such as Mathcounts, because Mathcounts isn't all based on memorization. A lot of the stuff is based on logic and problem solving and just techniques in general. So relax the day before the test. Try not to think about it and definitely don't stress about it. When I used to do Mathcounts, I used to take the day before and I used to watch TV and I used to just not think about math at all the day before. Just before the test, make sure you don't stay up late the day before. Don't do math the day before and make sure you go to sleep early. So that way you can wake up well before the test. Make sure you go to sleep by 8 o'clock and that way you can wake up at 6 o'clock. That gives you 10 hours of sleep, which is a lot of sleep. And then when you wake up at 6 o'clock by the time the test comes around, you're going to be well awake. Make sure you don't get too nervous because nervousness will never help you. There's no point in stressing out over it because you'll do just as good as you do and you'll do better without any stress or without being nervous at all. One more tip is walk outside before your test. Back when Mr. Norris was teaching at Stoller, before every Mathcounts tournament, we'd all have to walk outside in the cold. One funny story is Mr. Norris was from Vermont, so he would always walk outside in the winter when it was like half snowing and half raining in half sleeves. And we always thought this was insane, but this was just a fun story I had. And walking outside in the morning kind of wakes up your brain and it just helps you do better because your brain will be fully awake after taking a 10-minute walk outside in whatever temperature it is. And you get oxygen flowing through your body and clean air, and it's really good to walk outside before the test. And finally, the last point before the test is to eat a healthy breakfast. Make sure you eat a decent breakfast before the test. The worst thing that can happen to you during the test is that you're hungry, because you can't eat food during the test, and being hungry will affect your brain a lot. It'll make you get distracted and make you do a lot worse. So eat a good breakfast in the morning before the test. And not only this, you shouldn't drink milk or caffeinated drinks the morning of the test. A lot of people think milk is really good on mornings of the test, but milk has proteins that are bad for you, and not necessarily bad, but they have two things called tryptophan and melatonin, and these two things make you sleepy. So while in short term they might not make you sleepy, over the course of your 2 or 3 tests, they will make you very sleepy. So you shouldn't drink milk, and caffeine is also pretty bad for you just because it gives you a short high, but then the rest of the test you'll be feeling horrible.
Can you lower the PDF? I can't see the bottom part.
The bottom part is
Sorry,
just
that's overrun. We
Oh.
couldn't manage to fix it. Sorry about that.
yeah. But the main thing you gotta remember is just don't drink milk or caffeinated drinks. Just focus on water because water is your best bet and water will keep you the most healthy and awake during the test. All right.
Okay, so now we're going to go over some test taking strategies. So Nividh, if you want to take that off, I'll share my screen. Yes. Okay, can y'all see this? Or give me a thumbs up? Yes.
Yeah.
Okay. And you can hear me fine, right?
Yeah.
All right. So let's talk about kind of just math counts in general. Actually, not just math counts. These apply to other tests. Like I know the AMC 10A is coming up before math counts chapter, actually, and I'm sure a handful of you will definitely be participating in that. So this is applicable to other tests as well. So first of all, the results of the test are not the most important part. Math counts is not just, Anyway, math counts is an experience, not just the test. And there's so much more that you get out of it, no matter how far you get. And that's the most important thing to remember, is that as long as you're, I guess, as I said previously, the only person you're competing against is yourself. You want to improve every year, and that's the most important part. Now, of course, don't feel discouraged if you didn't do as well as you hoped, because I mean that doesn't mean anything. I mean, like for example, 2018 Nationals just this wasn't my day. It just didn't go that well. And the important is that you have to use that experience as motivation for the future rather than letting it discourage you. Now, as it says, don't just start doing more math just because you did that and you feel like you need to suddenly improve a lot. That's not true. And now here's the other thing. Stressing out and I guess obviously desiring too much is it makes you nervous and it'll actually make you perform worse. Now that's the thing. Kind of as the first time you do a test, you probably might not feel as much pressure. It's like, oh, it's my first time. There's nothing to compare myself against. Do however you want. But obviously, in future years, I mean, you might get better, but then you feel more stressed out. You feel more pressure to do well. So kind of just part of that, not letting the nerves get to you is kind of part of what determines if you do well. So kind of everyone has different ways of de-stressing. So whatever works best for you. And so so during the test, it's easy to think that, oh my God, I need to go faster. And sometimes, now I know skipping around in general isn't a great strategy. You want to start from problem one and go. But obviously, especially for math counts, skipping around too much, especially for math counts, if you have a problem that you know is going to take you a lot of time, maybe you know how to do it, or maybe you don't know how to do it, you're going to say, okay, this is going to take a lot of time. I'm going to come back to that one. That's okay. And sometimes even if there are later problems down the road that you do know how to do, sometimes those can serve as confidence boosters. And then you might just go back to those earlier ones. It's like, hey, I know how to do this now. So, but obviously too much skipping around isn't a good practice either. That can just add to stress. And if it's hard for you, it's hard for everyone. I mean, All right, speed and accuracy.
Alan, you're muted.
Oh, right, thanks. So when you're actually taking the test, there are two really important things you need to keep in mind: speed and accuracy. Well, for speed, remember that math counts tests are some of the quicker contests in the math contest season. In the sprint round, there's going to be only 40 minutes for 30 problems. And in the target round, there's 6 minutes for 2 problems each. And this varies based on the speed at which you need to go is going to vary based on how many you want to solve in these, but generally you're going to leave only a couple minutes per problem at best. So maybe it's best to find your pace. Know how fast you want to go for each problem. If a problem's taking too long, it's completely okay to skip that problem, as Suyash said. Know what pace you're accustomed to. But the other part is that you don't want to let that speed detract from your accuracy. when actually taking these problems, you want to be accurate. One really important thing is to read the problem multiple times when you take it. But so you should just focus on you should probably focus on the problem at hand instead of worrying about checking previous problems. There is a point when you do want to check some of the problems, but Mathcounts generally doesn't have enough time to check every single problem you solve. So being confident in your accuracy is important. Only check problems you're not sure about. For instance, if there's a problem where you're just not so sure about your calculations, you could put a star next to that problem and go back to it when you go back to the problems with stars when you feel like you just can't go any further. So, Ram?
All right, thank you, Alan. So that sort of covers most of the sort of test taking strategies. And I know we went a little fast, but that's because we wanted to keep time for what we're about to do, which is actual strategies for specific kinds of problems, and how you can improve at specific kind of problems. We're going to go through algebra, concepts like algebra, geometry, counting and probability, and number theory. So let me share my screen and you can see exactly what I'm talking about. So, like I said, what we sort of covered now is sort of general strategies while you're solving a problem and test taking strategies. But for actual problems, there are four main subjects that problems can be categorized in, which is algebra, geometry, combinatorics, which is counting and probability. So counting and probability are pretty similar. That's why I put them into one sort of subject. And number theory. So you might be familiar with different sort of concepts and problems that you may have done in these areas, but it's important to have a solid base in all of these four subjects. You might think that they actually have quite little overlap, these four subjects, especially actual problems, but especially in math counts, a lot of problems combine many of these sort of topics into one problem. So you might have a problem which involves, say, counting, but then also a number theory part to it, or a geometry problem where at the end you have to use some algebra to solve for something. So it's important to really have a solid base in all four of these subjects. This is the most general sort of way we can categorize problems, but yeah, just keep in mind that problems can involve multiple of these subjects in one. So we're going to go through each of these subjects, talk about general strategies in each, and we will use examples from previous math counts tests that aren't too old. Like Nividh was saying, it's probably best if you use tests that are not too old, because then they might get easier, the problems might be a little different style. But we're going to use examples for each of these subjects to sort of illustrate what we're talking about. And yeah, just remember that the strategies we're going to talk about, it's nowhere near an extensive list. It's hard to even come up with such a list where you can just say, here's a recipe for solving any problem. Math counts really relies on problem solving and sort of being able to think in many different areas instead of just applying the same strategies over and over. So these are useful guidelines, but again, they're not going to necessarily help for every problem, but practice is always good. All right, so the first subject is algebra. One thing to note is that many math counts problems that are algebra are hidden under the guise of word problems. So you sort of have to solve for what you're looking for by interpreting a word problem. For word problems, analyze what information is given and set variables to relevant quantities. Setting variables is a very important skill for word problems because you want to try to write equations for those variables in a way where you can both utilize the information given in the word problem, as well as extract useful variables to be exactly what you need is a very important skill for word problems. And in order to do that, the most important part of word problems is interpreting the text. So it can get a little confusing, three runners are running around a track and you have all sorts of setups involving the word problem, but it's very important to interpret the text properly. If you sort of miss one part of the word problem, which says like unique or indistinguishable or something like that, that could change the entire setup of the problem. So make sure you're reading the problem, especially for word problems, more than once. So yeah, once you involve variables and expressions, once you write down the right variables, then use the information already given in the problem. That way you can analyze what's given and continue from there. A common mistake is that if you have a variable that is not equal to what you're looking for, so for example, well, I'll go through an example, then you actually have to make sure you find the right answer. So for example, if you define the variable y, but the problem turns out to be asking for 12y, just write down y, circle the answer once you figure out what that is, and then forget that the problem is actually asking for 12y. I know this might sound silly, but it's a mistake we've all made before. So it's really important to go back and check exactly what you need. All right, so that's general tips for algebra problems, which mainly come in the guise of word problems. So now, why don't you guys try this example problem? That's why I said bring a piece of paper and pencil and try for a couple minutes, interpret the text, and we're going to go through it after that. So take a couple minutes to try and solve this problem. And if you have the answer, then make sure you don't send it to everybody on the chat. Send it to one of the hosts, which is one of us four.
Yeah, I think we've disabled public chat anyway, so.
Okay, cool. But yeah, if you want to check your answer, ask any questions, then feel free to ask one of us. This question is on the harder side of word problems and algebra problems in general, like sort of interpreting exactly what's going on, but that's why we're going to be going through tips on strategies how to solve it. So we're going to reconvene at 12:30, which is in about 2 more minutes. So just try to get a feel for the problem and ways to attack it. All right, take about another minute or so, and then we'll go through how to do it. All right, so let's go to this problem. If you're still working, feel free to continue, and you can always refer back to the slides, which we're going to publish, to check your work or see better ways to solve it. So it's important to spend a bit of time on the problem before we go through it, or else what we're going to say won't really be meaningful or helpful. So let's start interpreting this problem. So the problem statement itself takes a bit of time to digest. The first step is to interpret the word problem. So the cost of a dozen donuts is reduced by X cents. Let's say I have 12 donuts and I say the total cost of this box of donuts is going to be reduced by 24 cents. Well, that would mean that the cost of each donut has been reduced by 2 cents because 24 divided by 12 is 2. Say I just want to buy one donut from that box of 12, I would have to pay 2 cents less because the entire box was reduced by 24 cents. So that's just an example. Here, the cost of dozen donuts is reduced by X cents. So this problem is about sort of rates and that sort of stuff. We're going to work through the problem linearly using the information and see what we can extract. So like I said, the cost of 12 donuts is reduced by X cents means the cost of one donut is reduced by X over 12 cents. All right. And now the problem says if the cost of dozen donuts is reduced by X cents, a buyer will pay 1 cent less for X plus one donuts than something else. So we're going to interpret this part of the problem later, but the problem says a buyer will pay 1 cent less for X plus one donuts. So if the cost of one donut reduces by X over 12 cents, then the cost of X plus one donuts reduces by X times X plus one over X times X plus one over 12 cents, because the cost of one reduced by X over 12, so X plus one donuts, you multiply that by X plus one. So now the problem says a buyer will pay 1 less cent for X plus one donuts than if the cost of a dozen donuts is increased by X cents. So remember, we decreased the cost by X cents, and now it's saying if you increase the cost by X cents, you can sort of get a relation between the difference for the price of X plus one donuts. So the second scenario, we started off this case with, suppose the cost of 12 donuts is reduced by X cents. Now we want to analyze the case when the cost of 12 donuts is increased by X cents, because that is what we're comparing this to in the problem. All right. So the cost of 12 donuts is increased by X cents. Same logic, that implies that the cost of one donut increases by X over 12 cents. This is a very common trick or common strategy for rates problems, where you want to bring everything into a common sort of rate, which is, say, like how much does the cost of one donut change? And then you can use that to analyze how the cost of any other number of donuts changed. So for rates, you want to bring it down to a common sort of rate and then bring it back up to whatever you want. So for example, problems like painter 1 paints a house in 12 hours and painter 2 paints it in 18 hours. How much time would they both take combined? For those kind of problems, you need to say, okay, in 1 hour, you need to bring it down to a common. Painter 1 does this fraction of the house, painter 2 does this fraction, and then sort of use that as a root. So this is a pretty common sort of method for rates problems. So the cost of one donut increases by X over 12 cents. So the cost of X plus one donuts increases by X times X plus one over 12 cents. So now the problem says we'll pay 1 cent less in these two scenarios. So the difference in cost of these two scenarios is 2x x plus 1 over 12, because in one case we're reducing by X times X plus 1 over 12, and in one case we're increasing by X times X plus 1 over 12. So the difference is 2x times X plus 1 over 12, and we're given that that difference is 1 cent less. The logic here, I agree, is a little confusing, sort of wading through exactly what you know and the sort of differences is equal to 1 cent and all that, interpreting the word problem. But that's why it's very important to understand what the problem is saying and then set up the right variables and equations. So the difference is 2x times X plus 1 over 12, and the scenario and the problem gives that the difference in these two cases is 1 cent. So we can set up an equation. We set 2x times X plus 1 over 12 to be 1, and this reduces to X times X plus 1 equals 6, or X squared plus X minus 6 is 0. Now we just have a quadratic. We can solve it. In particular, this factors, you can see, as X plus 3 times X minus 2 equals 0. This is a well-studied technique for quadratics, which is to either try and factor, and if you can't factor, then try and use the quadratic formula. But here we got lucky and it factored. So either X is -3 or X is 2. It just says what is the value of X, how can we determine which one? Here's another case where you need to interpret the word problem. What is it really asking? If the problem was just given in very abstract terms, then sure, one of either -3 works or 2 works. But the way the problem is phrased in terms of donuts, you don't say a donut reduces by -3 cents, the cost of a donut. You really need to go back to the word problem and see what is implied by the wording. It only makes sense if x is positive, or at least it makes more sense. Luckily, one of our choices is positive, so we choose x equals 2. So recapping, the main sort of point of this problem was analyzing the rates, and really we had to go back to the word problem multiple times to see exactly what it was asking and how we could extract information from it.
One note, it's always helpful in these sorts of problems to check your work if you can. Maybe plug in x equals 2 into this problem and make sure that it actually works out and you didn't make a mistake through all this algebra.
That's for sure. So that's an example for word problems. Now, Suyash, want to take number 3? Now we're going to move on to a different subject, which is number 3.
Yeah, give me just a minute and I'll have this number theory problem up. Okay, so. Share screen. All right, thumbs up. Can you see that? Can you hear me?
Yep.
Okay, cool. So we're going to talk about number theory problems now. So now number theory is a wide area of mathematics. There are kind of many different kind of subtopics. There's like modular arithmetic, base number arithmetic, all sorts of stuff. So we'll talk about a few general strategies though. So some number theory problems have to deal with sequences. So there was actually, so it's asking you to find a certain term in a sequence or the remainder when that term is divided by a particular number. So actually there was a problem on the ALIME just in 2020 that was a sequence that gave the first 2 terms and then each term thereafter was recursively defined on the past 2. And what you found is that it had a period of 5. So after 5 terms, it just repeated it over and over again. And that made it very easy to find a 2020th term. Now, in this case, when you're being asked about a sequence, you want to compute the first 2 terms. And unless something is glaringly obvious, something else, then yeah, go try that path. But otherwise, if nothing else, just compute the first few terms. And almost always, you will find a pattern. Now, if you're looking for a remainder, like let's say you want the remainder when the 2021st term is divided by 6, then you can kind of work with modular arithmetic. So, for example, let's say you want the remainder when the 2021st Fibonacci number is divided by 6. Then what you can do is you can do, okay, 1, 1, 2, 3, 5. Now, 3 plus 5 is 8, but the remainder when 8 is divided by 6 is actually 2. And you can continue that way by adding up the mods. And we had a lesson on modular arithmetic earlier, so hopefully you're pretty familiar with that, but that's a very common strategy. Now, a lot of these number theory problems contain multiple parts. And these multiple part problems, you need to map out your steps for attacking the problem first. That's very important. And lastly, you always want to try to turn the problem into an algebra or a counting problem. So algebra, we just covered. Counting, you'll see in a moment. And this happens more often than you think. Often, number theory problems are just algebra problems in disguise. But yeah, so just some important concepts to understand include modular arithmetic and base number arithmetic. There's so much more, frankly, but these are some things you would definitely want to review.
And one thing if I'll just say, a lot of what we've been covering in Pacific math classes so far has been number theory, and we're definitely going to cover subjects in all 4 we're going to cover topics in all 4 subjects. So make sure you can attend those classes, and you can also learn more of these techniques if you haven't heard of modular arithmetic or other stuff Suyash was mentioning.
So now let's try a problem. This is from the 2013 Mathcounts State Sprint Round. The sum of 5 consecutive positive even integers is a perfect square. What is the smallest possible integer that could be the least of these 5 integers? Go ahead and try it for yourself. And we'll reconvene at 12:42. stop my share for just a minute. I'll try to get it back up as soon as possible.
I'll just share my screen while Suyash is down, just to, so you guys can see the problem. Try and note it down if you can, but there's a problem.
All right, we're back here.
All right, just take a couple, another minute, and then we'll get back.
I'll give it one more minute here, and then we'll go over the solution. If you're still working, that's okay, but just for the sake of time, we're going to start going over the solution here. Okay. So you want to let the middle number be 2a for some positive integer a. Obviously, we're calling it 2a because we know it's an even number. Now, why the middle number? Why not the first or the last number? You'll see that soon. Now, the 5 numbers are then 2a minus 4, 2a minus 2, 2a, obviously that's the middle number, that's what we defined, 2a plus 2 and 2a plus 4. Now, we know that the sum of these positive even integers is a perfect square. Now, if you sum them all up, you get 10a. That's a perfect square. Now, this is why we defined the middle number to be 2a, because if we had defined it as the first or the last number, it would have been like 10a plus something. That wouldn't have been as convenient. So we want the smallest positive integer a such that 10a is a perfect square. Now that's not too hard to see, but that number is 100. So are we done? Remember, we just went over this. A is not the answer. We want the smallest number. We actually want 2a minus 4. And 2a minus 4, that's 2 times 10 minus 4 is 16. That is the answer. So remember, we went over that earlier, that a common mistake in algebra problems is defining a variable that not equals the answer, and then solving for that variable, but just writing that down instead of actually going back in and seeing what that implies the answer to be. So 16, that's the answer. We can do a check here. 16 plus 18 plus 20 plus 22 plus 24. That's 10 squared, 100. So that is the answer. Okay. All right. Let's see. Alan or Nividh, finding probability now.
All right. So the next thing we're going to go over is combinatorics, which is basically just counting and probability, a fancy term for counting and probability. So most probability questions can be solved by finding the number of combinations that satisfy a condition and then dividing that by the total number of combinations. And since most probability questions are just finding the number of combinations that kind of fit some condition A, and divided by the total number of combinations, we're gonna go over counting strategies to count, because normally when you can count stuff, you can find the probability of anything. So first we're gonna learn about dependent and independent. So in a lot of problems, there will be multiple events, and each event can either be dependent or independent. Dependent means that one event depends on another event. So for example, let's say there's a 5% chance of snow if the temperature is above 40, and there's a 30% chance of snow if the temperature is below 40. The chance of snow is dependent on the temperature. So that's what dependent means, and independent means that the events don't depend on each other. So for example, if somebody flips a coin 10 times, each event is independent and doesn't rely on the other toss. So the second toss doesn't depend on the first toss. The first toss could be head or tail, and the second toss could also be head or tail, and the probability of the second toss being heads or tails does not at all depend on what happens during the first toss. So if the events are dependent, like our example with the snow and the temperature, then we approach the problem using casework. And casework basically just means that we look at it case by case. So looking at our snow example and our temperature example, we look at it in two cases. One case being that the temperature is over 40, one case where the temperature is under 40. And then we find the probability that it snows if it's over 40 and the probability if it snows under 40. And then we can add these together to find the chance that it snows on a given day. If it's an independent event, then it's much easier to solve the problem because we can simply solve it by multiplying the probability of each event happening however we want it to happen. And for probability questions, like we said earlier, the best way to solve these is by finding the cases where the solution or the condition works, and then dividing by the total number of cases. So our problem is a tetrahedral die whose faces are numbered 1, 2, 3, and 4 is rolled 3 times. What is the probability that the sum of the numbers rolled is 7? Express your answer as a common fraction. So we're going to give everybody a few minutes to do this, and then we will be moving along. For the sake of time, I'm gonna start working through the problem again. I'll go a little bit slow. That way, if you're still working, you can still stay ahead of me, and um, you can still work on it on your own. But I'll just go over it for everybody who's stuck, and just so that we don't take too much of your guys' times. So we will begin listing all the combinations of rolls that sum to 7, ignoring the permutations for the time being. And permutations, for anybody who doesn't know, is just the order of the numbers. If you roll a 1, 2, and 3, that's a combination. And permutation would be 1, 2, 3, 1, 3, 2, 2, 1, 3, and so on, all 6 orders of the 3 numbers. So if the largest number rolled was a 1 or a 2, then the sum can be at most 6. So if we take the 3 rolls and we find whichever number was the highest and it was 6, then if it was 1 or 2 that was the highest, then the total highest or the total sum can only be 6, and that's not equal to 7, so we can ignore the combinations where 2 is the highest. So if the largest number rolled is a 3, then the other two numbers must sum to 4. So there's two ways where the other two numbers can sum to 4. It can be 2 and 2, and it can be 3, 1. So our two combinations, if the highest number is 3, is 3, 2, 2, or 3, 3, 1. Now if the largest number rolled is a 4, and the other two numbers sum to 3, then the only possibility is 4, 2, 1. So we're ignoring permutations right now, and permutations, like I said, is order. We're just worrying about what three numbers kind of add to 7. So now we can look at permutations. So for 3, 2, 2, which is our first combination, there are 3 permutations, each representing one possible roll of the die. We can either have 3, 2, 2, 2, 3, 2, or 2, 2, 3. And we can also think of this as choosing one spot, the first roll, the second roll, or the third roll, where the 3 goes, and then the 2's fill out the other 2 spots. So there are 3 ways of doing this. Similarly, with our case where there's 3, 3, 1, there are also 3 permutations to this as well. Finally, for our last combination of 4, 2, 1, there are 3 different numbers, so there's 3 factorial permutations. And this is just because there's 3 ways of choosing where the 4 goes, 2 ways of choosing where the 2 goes, and then the 1 has to go in the last remaining spot. So the total possibilities that where the sum is 7 is 3 possibilities using our first case, 3 possibilities using our second case, and 6 possibilities using our third case, and this adds up to 12 possibilities. And each roll, each of the 3 rolls can be there's 4 possibilities, so our total number of outcomes is 4 cubed equals 64. So looking at this, we can see that um, our number of cases that work is 12, and when we divide that by 64, and 64 is the total number of cases, then we get that there's 3/16 probability that the numbers add up to 7. All right, Alan, I'm leaving it off to you.
Yeah, Alan is just going to take a bit to re-download it, but
Yeah.
you just want to go through the key learnings from the combo problem, Nividh?
Yeah, sure.
Because I feel like there's, yeah.
All right, so the next section we're going to go over is geometry. So
Just,
with geometry,
yeah, sure. Just,
with geometry,
yeah, never mind.
there's a few important steps, and geometry problems are really open-ended, so we're going to try to cover the best way to solve most geometry problems, but obviously some geometry problems have specific techniques which we aren't going to cover right now. So the first thing you want to do when you see a geometry problem is to download the problem. Draw the problem, sorry. So you want to draw the problem, you want to draw all the information that was in the problem, and you just want to make a diagram however you can. Then you want to label what you're trying to find out. So if you're trying to find out the radius of a circle or a side length or a line segment length, label it with some variable so that you can easily reference it and so that you know exactly what you're looking for, and you can kind of use the variable wherever you can. So you can use whatever variable makes sense to you at the time. And after you do this, you want to see if there's anything that pops out at you. So this step isn't so obvious, but just try to glance between using, uh, just try to like look at everything and just see, oh, is there something that might be a right triangle? Do I recognize 3, 4, 5 triangles? Is there something with a triangle with the length 3, 4, 5? That means there's a right angle. Just go through the problem and see what pops out at you, what you can notice. So a lot of times you'll notice right angles, and you'll also notice a lot of times that 2 lengths might be the same when you look at the problem. Then you want to solve for everything you can. You want to solve for all the sides, all the edges, and all the points. You want to solve for everything you can using the information given to you in your problem and using the information you got from the previous step. And once you do this, it'll be a lot easier to solve the problem. And a useful tip when you're stuck is to try to find similar or congruent triangles. These help a lot with finding angles and sides, and it might not be so easy to like see these, but if you're stuck, you can look around and try to find any triangle that's similar or congruent, and then this will help you move along in the problem. And finally, drop altitudes to utilize the Pythagorean theorem. If you have a triangle and it's not a right triangle, you can make it into 2 right triangles by making the altitude from one side or from one corner and making it with a right angle to the opposite side. And this is a lot more useful than a lot of people realize. So just try to, if you're stuck, then you can just try to make right angles by finding the altitudes of triangles. All right. Now I shall give it to Alan.
All right. So our problem is, what's the radius? What's the radius of a circle inscribed in a triangle with with sides of length 5, 12, and 13. This is a bit of a tricky problem, like many geometry problems are, but first to draw a diagram, try labeling the lengths you can. Take a couple minutes.
Alan, do you just want to describe what inscribed means for people who might not know what that
Yes.
is?
So for instance, let's say, let's see if I can.
Maybe you can just explain it if you can't find the drawing tool or anything like that.
Okay, so so basically, if we have a triangle, an inscribed circle is one that's tangent to all the sides on the inside. All right, I'm going to try showing a. Let's first note on this problem that the triangle is a right triangle by the Pythagorean theorem, since 5 squared plus 12 squared is equal to 13 squared. So we can draw our right triangle. That's very important, and 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 draw our circle and connect the center to the points of tangency. Another really important thing in these sorts of problems is that the point where a radius of a circle touches an touches a side as at a tangent is that forms a right angle. So that's going to be really key in this problem. So since this is a right angle, this is a right angle, this is a right angle, this has got to be a right angle, this means that that's got to be a square. That means we can label our sides. So this is R, this is R, this is R, this is R. Since this side length is 12, and this side length is 5, then these have to be 5 minus R and 12 minus R, respectively. Now, in order to figure out these two sides, the trick is to notice that this triangle and this triangle are congruent because, first of all, they have that same right angle, they have the same hypotenuse, and they have the same leg of R. That means that these two sides are going to be the same. This has to be 12 minus R. So this has to be 12 minus R as well. And similarly, that is 5 minus R. Now, what can we say about the radius then? We have that okay, that wasn't completely typed out, but 5 minus R plus 12 minus R is equal to 13, which means that 17 minus 2R is 13, or R is equal to 2. That was fast, but we can go through the example. You can go through the example again to understand on our website if that was confusing. So before we end, uh, we have some weekly Monday classes if you aren't already joining, from 5 to 6, teaching classes on various math topics about math counts, AMC, that sort of thing. You can You can join them at no cost. Sign up at this website. The link is in the chat. Contact with questions or suggestions at this email. And Nividh, we're gonna end, I believe, with a Kahoot.
Yep, we're going to be ending with a Kahoot, so I'm going to share my screen, and everybody can go ahead and join the Kahoot.
Yeah, the Kahoot will be a countdown style. So countdown is another sort of fun round in math counts outside of sprint and target, where I'll just talk for a bit explaining what it is while people join. But a sort of fun round where people can do math counts problems quick and just sort of have fun. So for here, yeah, go to kahoot.it, the website kahoot.it, and enter the pin, which is 5701083. Nividh, you want to enter the pin in the chat just in case people can
Yep.
see?
So just for everyone, the pin is in the chat right now, 5701083.
And yeah, again, these are going to be a little fast, so they are going to be a little easier. But for problems that we were doing before, which were more, harder but involve more techniques, you can definitely learn more of those at our weekly classes. All the handouts have been uploaded as well. So yeah, definitely join. There's going to be a class tomorrow, just from 5 to 6 p.m. So make sure you join. We're going to be sending a reminder email. But yeah, we hope you found this session useful so far. And we'll just end off with some countdown and then let you guys go. All right, you want to?
Yep, I will start the game, but it is open, so if you haven't joined, you can still join using the code in the chat.
Yes, we're going to have 20 or 30 seconds per problem. So take your time. So we won't be going through exactly how to do each problem, but if you have any questions, you can feel free to ask.
Yeah, guys, that was the square root of 324. That's 18. So 81 times 4, 324.
Remember, these are integer solutions. So for this, try to say it's between -8 and 8 and try to work from there. Yeah, before we go to the next one, maybe I can just say, so it's between -8 and 8. So we have -8 is between 5x minus 3, and which is less than or equal to 8. So -5 is less than or equal to 5x is less than or equal to 11. And now you can just narrow down the values of x for integers. So this is a pretty fast kind of question, which is countdown style. All right, here's the next question. Yep, this is just 7/9 because when you simplify the fraction, you're going to get the same numerators in both the top and the bottom. All right, next question. A word problem. We covered a bit how to do those. All right, yeah. There was just 15 and 10. But... All right, so this is a problem about medians and modes. You want to find sort of extremal list. So yeah, we won't be going through exactly how to do it, but the trick is to find an extreme kind of list. All right, here it was yeah, you can find the side links in the computer. All right, there's the next one. Yep. Right there, you just wanted to simplify the square roots, and then
2 root 2 plus 5 root 2 is 2 root 2 plus 3 root 2 is 5 root 2.
All right, so this is kind of a question about mods or seeing how you can use divisibility tricks, but so it might be a bit quick. But, the trick is to say it's divisible by 9 and 11, so the sum of the digits is divisible by 9. I won't go through exactly how, but from there you can solve for A and B. Okay, final question, and then we're gonna end pretty soon after. All right, 50 exclamation is factorial, remember. This is the cute one. All right, it's actually 0 because 50 factorial has a 3 and a 17, which is divisible by 51. So 51 is 3 times 17. It has a 3 and 17. All right, congratulations, Sahiba, Anshu M. And number 1 is just a dollar sign. All right, well, I guess money wins at the end. Anyways, thank you everybody for attending, and please feel free to attend our classes, which happen on Mondays. So next one is going to be tomorrow. We hope you really benefited from this seminar, and yeah, please feel free to email us any comments or questions that you have. Thank you for attending. Hope to see you soon. Thank you. Bye. We'll stay back for a couple minutes if anybody has questions.
Thank you.
Thank you all for coming.
All right.
Thank you all.
Thank you. Bye.
Bye, everybody.
Thank you.
Okay.
Thank you.
Closing the
Bye.